In this example, a researcher was interested in if the average U.S. salesperson's salary differs from what the national average salary is. They want to see if there's a difference, any type of difference between them. So what they did is they took a sample of random salespeople's salary to test this hypothesis. So our hypotheses for this test are that the mean equals the hypothesized salary of $63,500, and that is the national average, the 2019 national average. This researcher is trying to see if it differs from that national average. Now, before we go ahead and start our test, we need to make sure we check our conditions. Right? We need to see if there is a random sample. And in this problem, it was stated that there was a random sample of salespeople. Right? So cool. We need to have our sample size being at least 30. Right? In this case, our sample size is 49, so both of these are rocking and rolling. And our last one is that our sample size needs to be less than 10% of the population. Well, we don't know for a fact, technically, but I think it's safe to assume that there's more than 49 times 10, or 490 salespeople in the United States. So we should probably safely assume that this condition is met as well. So now that our three conditions are rocking and rolling, let's go finish this hypothesis test. So the next thing we should do is find our test statistic. And we can think of this as like a t-score. Since we're estimating a mean, we're going to be using a t-distribution. So what we'll do is we'll take our sample mean, which is $67,200, and we'll compare it to what we're assuming the population mean to be, $63,500. So that's our assumed population mean. And we'll put this all in terms of standard deviations or standard errors. Right? Our standard deviation in this problem is $94,222. And we'll divide that by the square root of our sample size. And if we were to do this out, we would get approximately 2.75. So I'm going to go over here, and I'm going to draw these distributions out. So we have one distribution we can think of in terms of our sample mean world, and we have another distribution in terms of our t-score world. The center of our original distribution is $63.5 thousand, and our sample mean was $67.2 thousand. And we turn this into a t-score or a test statistic of 2.75. Now our original distribution has a mean of 63,500 and a standard deviation, like we just saw, of 94,222 divided by the square root of 49. Our new distribution is a t-distribution with degrees of freedom 49 minus 1, so 48 degrees of freedom. What we're trying to do now is find enough evidence to support that the mean differs from 63,500. So since our HA does not equal to, if you remember, what we do is we create a positive and negative test statistic. So our test statistic should be both positive and negative. So we'll create another test statistic, a negative 2.75, and we're going to try to find the collective outside area. This collective outside area. This area will be our p-value. To find this area, we'll need to go to our t-distribution calculator. So for our t-distribution calculator, we have 48 degrees of freedom. right? Our sample size minus 1. And we're trying to find the area associated with everything outside of 2.75. And so what this did is you can kind of see there's a blue shaded or a blue line right here, and there's a blue line right there. Selecting this option finds the collective outside area regardless if your test statistic is positive or negative. This gave us that p-value that we were looking for. And it turns out that area is 0.00838 or 0.838%. Now that we have our p-value, the probability that we were looking for, let's go back to our problem. We found this area to be 0.0838, which is our p-value. We'll compare that to alpha, which in this problem is 0.02. Since our p-value is less than alpha, what this does is this gives us enough evidence. So I'll write evidence to reject our null and to support our HA. That the population mean salary for salespeople is different than the national average, is different than $63,500. We found enough evidence to support that. This is how we would do a hypothesis test problem when estimating a mean. Very similar to that, what we first learned with proportions. Now we're just using the formulas associated with estimating a mean and the t-distribution associated with estimating a mean, but the concepts we learned about hypothesis tests all stay the same.